Let's start. So the other day, we were discussing what, guys? We were discussing variance, standard deviation. Fine. So just to give a recap, and we have seen the example also. Fine. So we have seen a beautiful example where we have understood that blindly going by the mean will not be always helpful. Fine. We should also consider different dispersion measures like standard deviation, variance, so that we'll have a complete picture and understand uh, what is a variation and who is more reliable, etc., etc. Fine. So now the next topic we are going to study over here is called as covariance and correlation. Okay, let's study covariance and correlation. Fine. So first of all, to start with, what is covariance and what is correlation, and what is the need to study this? Okay, first of all, let's try to understand those concepts. Fine. See, here, the point here is the fundamental reason why we are studying all these is, as I said multiple times, to use all of these in the machine learning concepts. Fine, in machine learning concepts. In simple words, what is machine learning, guys? In machine learning is you have an input. Fine, you have an input. You are giving to a model. Okay, as of now, model you can treat it as a black box. You don't know what is inside that, but you will be knowing future, right? But just understand that when you give input based upon its training, model will give you some output. Fine. So that means based upon some input, model is giving you some output. But now the important point over here is what is the input over here? Okay. Uh, my voice is not that great. Yes, sorry. Okay, please bear with it. So the important point over is input could be multiple inputs. Fine. For example, if your output is to predict the house price, okay, my output is I want to predict the price of a house. Fine. My input could be different things. Agree? So what are the different things? Could be number of bedrooms, facing of the house, square feet of the house, fine, location of the house, fine. So all of these inputs, okay, all of these inputs will influence the price of the house. Agree? All of this will influence the price of the house. Now the important point here is for every column you are considering over here, it is very common sense to observe and understand that there should be some relation between the input column and the output column. Fine. Only then you can see some change. Whenever you are changing the input, you should be able to see some change in the output. Fine. In other words, there should be some relationship that should be already established between the input column and output column. Fine. If not, then how the model will understand? Fine. If not, how the model will understand, right? Are you getting this? What I'm trying to say? See, I'll try to. Okay. Fine. So the point here is, as I said, you can have input one, okay, input two, fine, input three. Fine. So what this input could be? This could be number of bedrooms. This could be square feet. Okay. This could be what? This could be uh facing. Okay. And the output is what? Price. Simple. Now what we are doing? Model we are training. Okay. We are training a model, machine learning model, and it will understand the relationship between the input and output. Fine. So after that, the only job of the model is whenever you give a new input, it should give a corresponding output. Fine. That is what any model will do in simple terms. Give an input based upon the training, I'll give one output. That is a fundamental job. But now to if you think and observe, there should be some relationship between each and in every input column and the output column. Fine. Only then the model will understand the relationship between this input and output, right? So if at all there is no relationship between these two columns, then what the model will understand during the training phase? Fine. If there is no relationship that is already existing, Fine. So now that's the reason for every input you are considering over here. Fine. There should be some direct or indirect relationship that should exist with the output. That means what? If you are changing this column, if you are changing the values of this column, that should directly affect this output column. Okay. That means what? So what is this number of bedrooms? So if the number of bedrooms are increasing, fine, that should affect the price. Either the price should increase or decrease, some effect should be there. If the number of square feet is increasing, that should affect the price. If the facing is changing, that should affect the price. Fine. So only then there can be some relationship you will have, and then you can study, and then you can make some parameters. Fine. So the fundamental reason why we are trying to study the covariance or correlation is to understand, if given two columns, fine, if given two columns, is there any relationship that is existing between them? Fine. If it is existing, then what type of relationship it is? If it is not existing, then there is no point studying those columns. Fine. Getting, guys? Are you getting the able to understand the fundamental concept what we are going to study? Okay.
Yeah, something.
See, now coming to correlation. Fine. Now coming to correlation and covariance. These two are the techniques or tools, you can say, which will help us to find out, if given two columns, fine, if given two columns, if there is any relationship that is existing between these two or not. Okay. There are two ways which you can study. Fine. So first thing is the covariance, guys. Okay. So the first thing will be the covariance. Fine. So I hope you are trying to understand. Fine. So the only thing we are trying to study over here is, if at all there is any relationship that is existing or not. Okay. So only that. Okay. Just keep that in mind. You'll also, once we see some examples, right? So it will get more clear to you. Fine. So now, first thing is, we'll see the covariance part. Fine. So over here, yeah. If you see covariance will tell you. So we will see the formula and we'll also see the example, but just understand that if at all, if sorry, if at all there are two columns, okay, if at all there are two columns, A and B, fine, A and B, if you try to plot them, fine, and if at all you see a downfall in the graph, okay, so it is starting somewhere and it is decreasing. What does that mean? So here, if you observe what's happening, so I'll show you. Okay, yeah. So let's say this is some A, okay, this is B, fine. So now if at all my covariance, fine, first let's see covariance. Okay, if at all my covariance is looking this way, how it will look? For example, let's say, simply let's take a simple example as A is height. Okay, A is height, fine, and B is weight. Okay, B is weight. As an example, you can try use any different columns, but as an example, height and weight. Now, simply, if the height is normally, if height is what, like 4, fine, the height could be some 40, just as an example. So if I take a direct relationship, if the height is 5, so it would be some 55, fine. So as the height increases, fine, as the height increases, the weight also increases. Okay, so if it is increasing, then let me write it this way. Yeah, yeah, okay. From 4 to 5, if it is increasing, fine. From 40 to 55, it is increasing. So as the height keeps on increasing, weight also keeps on increasing generally, guys. So if at all you are having 4, 5, 6, like that, Fine. So now if you're having some 40, 50, fine, and 60, okay, something like that. So if you start plotting these values, see, 4 will be 40, 4 and 40 will be somewhere over here, fine. 5 and 55. So here you will have something 55 over here. So here you will have 5, fine. And 6 and let's say something over here, fine. So now if you start joining these points, so you are going to get a graph, and as you can see, it is increasing. It is increasing as the values, both of them are increasing, fine. That means what? As you are increasing the value of A, fine, the graph is going up, right? From here you are going up. Similarly, as you are increasing the values of B, the graph is also going up, fine. So if I just draw it in a better way, so you will have in this way, okay. So now to give you the terms, there are three types of covariance, guys, fine. As you can see here, there will be three types of covariance, fine. One will be positive covariance, one will be negative covariance, and third will be the zero covariance. If at all, if at all a particular, if you consider two columns, and if a value of one column is increasing as the value of another column is also increasing, right? If one column increases, if the second column also increases, or if one column decreases, second column also decreases, then it should be concluded that those two columns have a very good or large positive covariance. Getting, guys? If you see here, if age is increasing, sorry, if height is increasing, weight is increasing, agree? That means if I see it reversely, if height is decreasing, weight is also decreasing, agree? That means if two columns, if the change in one column is exactly the same in the other column in the same direction, fine. That means if height is increasing positively, that means if increasing, then weight is also increasing, fine. If the height, if you consider height decreasing, weight is also will also decrease, fine. That means positive positive, negative negative, agree? Positive positive, negative negative. That means in those cases are known as what? Positive covariance features or positive covariance columns, or you can say there exists a very good positive covariance between these two columns. Getting, guys? Did you understand this? Let me know.
Yes, sir. Yes, sir.
Okay, fine. So now, as you can simply guess, now what will be the negative covariance? Now, there might be a slight confusion here. So usually people will think positive covariance means there is some covariance, negative covariance means there might be no covariance. People might usually think, I don't know if that you are thinking or not, but this is completely wrong. Positive, whether it is positive covariance or negative covariance, okay, it means that there is very good relationship that is existing between two columns, okay, either positive or negative. Forget about a minute. First of all, if there is any covariance or not, that is important, fine. So that means what? See, you are having a you are having number of bedrooms, right? If number of bedrooms are increasing, house price is increasing, okay. If this is increasing, house price is increasing, that's fine. If facing is changing, okay, if let's say from if facing is changing, the house price might decrease, okay. For example, most of the people don't like south face houses, just as an example. Some people might like east face, okay. Now if I'm changing from east face, okay, to south face, the house price is decreasing, okay, from let's say 50 lakhs to it might come to 30 lakhs, just as an example. So it's decreasing, fine. So that means what? So fine, so the facing might not be a great example here, because you cannot directly say, because these are categorical values, you cannot directly say going from east face to south face is increasing or decreasing, right? But number of bedrooms might be two, from 2 to 3. If it is going, obviously it is increasing. From 4 to 2, if you are coming, obviously it is decreasing, fine. So let's not consider the facing example, fine. So can you tell me any one due to which the house price might decrease, fine, if at all? Yeah, number of years, right? So age, fine. If age of the house is increasing, that means the age of the house, the price will decrease, obviously, right? So fine. So if the age is 0, that means it's a brand new house. Obviously, it might cost like 1 year, as an example. If age is constantly increasing, fine, the price will obviously decrease, fine. So in those cases where if the relation, if the increase in one feature is resulting in a decrease in another feature, or if the decrease in one feature is resulting in an increase in another feature, fine, that means in these cases here you have a covariance. Here you have covariance. Okay, first thing is you should understand whether you're having covariance or not. That means if at all changing of one column is changing other column or not, whether it's positive or negative will come next. Okay, we'll understand. Okay, but just because it is changing natively, don't think that is not a covariance, fine. So here also, if age is changing, price is definitely changing. As you can see, clear change. If it is 50 years old house, obviously it will cost very, very less. So obviously there is some effect that is happening on price when you are altering the age factor, fine. So this type of covariance where positive, if it's one is positive, other will be negative, or if one is negative, other will be positive. This type of covariance is called negative covariance. Getting, guys? This type the covariance will tell you negative covariance. Fine. So in this case, okay, in this case, if you try to just plot a graph, how it will look like, guys. So let me take this as a graph, and if I just say this as the as we have seen age, okay, and as we have seen the price, fine. Now, initially at the almost zero price, zero, okay, let me take 10, okay, 20, fine, 30, fine, 40. At zero age, that means very new built house, it might give you like 1 CR, fine. After that, for 10 years, the price might decrease a bit. 20 years still decrease, 30 years still decrease, 40 years still decrease, 50 might decrease again, fine. So now if you try to plot a graph, so it will be down, it will look like a downfall graph. Agree? So that means you can clearly see if what is x-axis age. If age is increasing, that means obviously this direction is increasing, right? So if you are increasing, you can see the line is coming down, decreasing. Agree? Or the other way around, if age is decreasing, if you start from here and try to go back 40 years, 30 years, okay, age is decreasing, fine. As you can see, you're going from this direction to this direction, the graph will go up, the price is increasing. Agree? As you can clearly see, there is a reverse relationship between these two. That means there is a very good relationship. That means there is very good covariance that is existing between these two. But that is what? That is negative covariance. Getting? This is negative covariance. Okay, that means if one increases, other decreases. If one decreases, other increases. But coming to positive, in the same example, for the same price, you can clearly take what? Uh, the example of a square foot. Square foot will be a very good example. So if the square foot increases, obviously the number of, so let's say like 1K, 2K, okay, 3K, that means 1000, 2000, 3000 square feet, okay, square feet area. Obviously the the house will also increase. So for 1K, it will be somewhere over here. Right? For 2K, it will be here. For 3K, it will be here. 4K. So obviously there will be an increase, clear increase. That means if this increases, this also increases. Square feet decrease, house price decrease. Fine. So that means it exists a perfect positive correlation. Same direction, both are changing. Getting this? Is this clear? Positive and negative?
Yes, sir.
Cool. So, but now if you see, you might be having one more covariance where the effect of one column will not result in any other effect in the other column. Okay. That means what? If the column one is price, okay, the column one is price, fine. And if the column two, what shall we take, guys? What will not have any effect in the price of the house? Height. Okay, fine. Obviously, the height of the person. Let's take. Okay, height of the person. height of the owner or what. So the height of the owner, if it is increasing, will it have any effect on the price? No, obviously no, right? Fine. So if you try to plot a graph, so it will be something like this. It will be something like this. Fine. You cannot see any, yeah, like this. You cannot see any perfect relationship between this. You cannot take a decision like whether it is affecting one column or not. Fine. So obviously this type of columns are called nearly zero covariance. Okay, that means there is no relationship that is existing, because no matter what's the house, what is the relationship between the price of the house between from the height of the person. Fine. So there exists three cases. Fine. So always remember, you'll have positive covariance, negative covariance, zero covariance. Positive covariance looks like this, a upward graph, where if positive, positive, negative, negative. Negative covariance will look like a downward graph. It will be positive, negative, or negative, positive. This will be zero, no relationship covariance. Okay, fine. So I hope you are good with this. Okay, I hope you are able to understand these concepts. Fine. So now, if at all, yeah, if at all, if I try to think of some other examples. Okay. Uh, See, there might be different sorts of examples, I would say. Fine. I'll come to examples when we discuss correlation. Fine. So we'll have a better idea. Now you understood covariance. That means what? Now if you just try to extend, these concepts, where you can use simply, you have column one, you have column two, right? You have column one, a group of column, you will have clear all values, you will be having 100 values in a data frame, you will have column two. Fine. So you'll have 100 values. So you need to calculate the covariance between these two. Fine. So we got the theory, background theory. Fine. So now let's try to understand the formula, how you can calculate this. Fine. So here, as you can see, this is a formula, guys. Covariance of x and y. Okay. This is for population. This is for sample. Fine. The only difference you will find between over here is for population you will have n, and for sample you will have n minus 1. And this reason we have discussed the other class. Fine. So, but just the important point here is the formula, even though it looks big, it's like pretty damn simple formula. Here, what's happening? You are having two columns, x column, y column. Fine. X is having a group of, let's say, 100 values. Okay. 1, 2, 3, 4, 100 values it's having. Fine. And y is having another group of 1, 2, 3, 4, 100 values. Fine. This could be anything. Okay. Age of the house, price of the house. Perfect. Now, how do you calculate the covariance of this? Very simple. For every point, take that point, take first point minus its mean, x dash. As you can see, x dash. So the other day I was saying the mean will be denoted in multiple ways. You can call it as x bar, you can call it as x dash. Fine. You can simply call it as mu, you will call it as mean. Okay. And you will call it as mean. Okay. Different ways. Okay. All this were referring to mean. So as you can see, x dash, every point in the x minus its mean, into every point in y minus its mean by n. That's it. That means what? If the mean is, let's say, 45 for x, and if the mean is 55 for y, so you'll do 1 minus 45. This is what? 1 minus 45 into the first value 1 minus 55. Okay. Plus summation, right? Second value minus mean into second value minus mean. Like that you will do for all 100 values, and you are going to divide by 100. Fine. So whatever you are going to get over there, whatever you are going to get from this, that is the covariance of these two columns. Okay. That is the covariance of these two columns. Agree? So if you get a positive value, that means you are having a positive covariance. And if you get a negative value, that means these two values are having a negative covariance. Fine. So this is a formula. Is the formula clear, guys? Because as you can clearly see, it's a very simple formula. Fine. So let me know if this formula is clear. If this, just let me know, if at all given two columns, will you be in a position to calculate the covariance and tell me? Just separate each value from its mean. I think you already know by this time how to calculate the mean of any given column. Fine. Calculate two means of two columns and divide it from each and every element one at a time. Add those, divide by n. Same thing goes for sample, but here the only difference is n minus 1 you need to do. As you can see, x dash and y dash are the mean of the given sample set. N is the total number of samples. Xi and yi are the individual sample set. That means each individual value from the given total set. X dash and y dash are the means of the given sample sets. Clear, guys? Formula?
Yes, sir.
Fine. But now there is a problem with this. Fine. So as you can see, now you should get a doubt. Fine, Santosh, you are saying covariance where this is a concept positive negative. We understood that if it is on one increase, it's very simple. In many, normally also in daily day to day life also, you will see, you can see hundreds of example, guys, right? So exams, okay, fine. In exams also, you are what do you say, number of hours you study and the marks you score. Fine. Any two values, any two columns, you can simply think of and try to understand if there is any relationship, positive or negative or zero. Number of hours, if it is increasing, if you study for more hours, more marks you can get. Fine. And your expenditure, if your expenditure and your savings, simple. If your expenditure is increasing, your savings will decrease. Clear? If you spend more, you will save less. Agree? You can think of hundreds of examples. Fine. So from day to day life. Fine. So like any example you take, that will be falling into one of these three. It will be positive or it will be negative or zero. Fine. Now now the important point over here is, why to study correlation when we already have something very useful and important as covariance. What is the scope for correlation? Why did this come into picture? Fine. Let's try to understand this. Now the problem with covariance is, it is wonderful, guys. With simple formula, given any two columns, it can give you covariance. It can tell you, hey, positive relationship exists. Because you might think, sir, by looking at the column we can understand that, but it's not the case always, guys. Because you will not work with 10 to 20 columns. Fine. You will work with hundreds of thousands of columns. Fine. So if I give you like a 10,000 rows of age and 10,000 rows of price, by looking, if it is age and price, obviously you can take a guess. But if I say column 1, 10,000 rows, column 2, 10,000 rows, by simply seeing, you cannot tell whether they are positive or negative correlated. Fine. So that's why covariance will definitely help you. Fine. But the only problem with covariance here is the only problem with covariance over here is the values what we are going to get. Fine. So there is no limit for these values. There are no limit. That means, if at all, let's say I'm having c1 and c2, and if assume these are positively correlated, and if at all you put these values, okay, if at all you put these values into this equation, okay, it might tell you, it might give you positive value, but let's say it is giving some 545. Okay, it can give you 545 plus 545. That means positive 545. That means it is saying there is some good relationship, positive relationship that is existing between these two. Okay. But if I give you some other c1 and c2, here also, let's say there is some very strong positive relationship that is existing. Okay. Just to make you guys understand, taking age, price, square feet, price. Fine. Okay. Age and price will have negative correlation, right? Okay. Let me take simply number of bedrooms and price. Now, number of bedrooms and price are having positive correlation. Agree? Square feet and price also have positive correlation. Agree? Now, the problem with covariance over here is, if you pass bedroom and price, obviously there is a positive correlation that is existing. It will understand that, it will give you some positive value. Let's say it has given 969. Fine. Based upon the values. Plus 969. Now, if you give square feet and price, guys, try to understand here. This also having positive correlation, this also having positive correlation, but the strength of the correlation is much more stronger for these two, because if square feet is increasing, definitely definitely the price should increase. Fine. If the bedrooms are increasing, it might not be always, because in the same place you can construct 3 bedrooms. In the same place you can construct 2 bedrooms, or if you want small bedrooms, you can construct 3 to 4 bedrooms. Fine. So just because you are increasing the number of bedrooms, you cannot always say the price is increasing. Agree, guys? Getting? So if I'm having this much area, okay, in this only I can construct 2 bedrooms, the price will be something. But if I just construct three bedrooms here, I cannot quote more price, right? Because the area is same. I'm getting the same area, man. Because if you're dividing this into 2, my size of bedrooms are decreasing. So just because you are increasing number of bedrooms, you cannot charge me more. Fine. Okay, due to some decoration, you can slightly increase. Okay, if number of two bedrooms is, let's say, 50 lakhs, if you are going for 3 bedrooms, you can charge like 52 lakhs, but not more than that, because you are dividing the number of bedrooms in the same area. Getting? But coming to square feet, if this much is costing 50 lakhs, if you are increasing to this much, obviously this will cost 65 lakhs, something like that. Okay, if you are increasing more area, obviously it will reach 70 lakhs. Getting? Even though both of the columns are positively correlated with price, but the strength of the correlation, sorry, but strength of the covariance, fine, the strength of the relationship between these two with the price is different. Fine. So one might be a little covariance value you can have, that means a little relationship, strong relationship, positive relationship you can have. Other column might be extremely strong. Fine. So the problem with covariance is, if you pass bedrooms and price, it will understand there is a positive correlation, covariance is existing. It will give you some value. And if you pass square feet and price, obviously it will understand there is a still stronger covariance that is existing, or relationship that is existing between these two. It will give you some other stronger value, like it might give you like 10,569. Okay, based upon its strength. Fine. So it will give you. By looking at these two, you can just understand, okay, these two are positively related. Fine. But the values are very confusing, guys, because what does this mean? If one value is 969 and one value is some 10,000, if you give some other value, if we give you some 1 lakh value, now we cannot compare these two, right? How can I, if I ask you, hey, how much more, how many times the bedroom and price relationship is less than or greater than the relationship of square feet and price? You cannot tell me, because the values which you are getting are very very vague. That means very very different, or you cannot quantify them. You cannot definitely say, hey, this much is the strength of these two, this much is the strength, and this is 3 times greater than that, or this is 5 times less than this. Fine. You cannot quantify them. Fine. Because of the values which you get from the covariance part. Fine. You cannot directly quantify them, the values. Fine. That will be the problem, that will be the fundamental problem of this covariance, guys. Fine. Because the value, the output, obviously you can know, okay, if you're getting positive value, fine. If you're getting negative, if at all the two columns are negatively correlated, like age and price negatively correlated, if you pass them, it will give you a very large negative value, saying that minus 4,335. Okay, but you can understand by negative value, okay, these are negatively correlated, but what does this 4335 mean? It is a big number, but what does that number mean? Fine. So because of the value of what we are getting over here, that is not always you can quantify, or it is not mathematically comparable with any other covariance values. Getting, guys? So that is the reason, obviously, in statistics or anywhere, you need something quantifiable, right? You should be saying, hey, this car is 5 times costlier than that, or 2 times cheaper than this. Fine. You should be able to tell that. Otherwise there is no use studying. Fine. So because of this problem, there we brought one more guy into picture, and his name is what? Correlation. Fine. So he'll also do the same job. Fine. He'll also do the same job. The correlation person who are seeing here, he'll also do the same thing. Positive correlation, negative correlation, no correlation, exactly the same. Two columns, two columns, two columns. If positive, positive, negative, negative. Guys, I'm repeating this, just try to understand and remember. Just because two values are negative, that means if one is decreasing, other is decreasing, don't think it is negative. Just if both are same, it is positive. Okay, don't get confused. Only if both are opposite, like if it is positive negative, negative positive, or if the positive and negative are confusing, just forget about this. Okay, increasing and decreasing you can take. Fine. So if one is increasing, other is decreasing, or if one is decreasing, other is increasing, that means there is a reverse relationship. Only then it is called as negative correlation. If both are in the same direction, pause, increasing, increasing, decreasing, decreasing, okay, both are decreasing, decreasing, then also it's called positive correlation. This one, positive, negative. If nothing affecting each other, then it is some zero correlation. Okay, so don't get confused over here. Fine. So these types of examples, fine. So you can think of many other examples. For example, if I just tell you time spent, okay, time spent on exercise versus body fat. Okay, body fat. Can someone tell me guys, what is the relationship? Okay, now let's talk about correlation. Okay, same concept of covariance. The relationship, the same, whatever we have studied, same will be applied. Only the values will be different. I will come to that. But now you can use the word correlation. Okay, as I said, if both are increasing or both are decreasing, it's a positive correlation. If it is a reverse, it is negative, zero. Now if someone can tell me what is a correlation between time and body fat, time spent on exercise and the body fat, what type of correlation does exist between these two, or will there be any zero correlation? Let me know, if you understood the concept.
Yeah, if you put more effort, then it may decrease body fat.
No, no, just tell me positive, negative, zero.
Negative.
Okay, if you spend more time, the body fat will decrease. Okay, that means there is some negative correlation that is existing. Perfect. Now if I ask you temperature, okay, that means environment temperature versus ice cream sales, ice cream sales. Now
Positive.
positive. Agree, everybody? Okay, the temperature is increasing, ice cream sales will increase. Clear? So that means there is a positive. Now, one more thing, shoe size and salary.
No correlation.
No
No
correlation.
correlation. Got getting? So this will be the negative, this will be the positive, this will be no correlation. Same thing what we have studied the concept. Fine. Now this you can extend to any two columns, guys. Fine. So this you can extend to any two columns. Okay, you can simply understand. And but now the very usefulness of the correlation here is, now you said for temperature and ice cream sales are having positive. Okay, and there might be another, for example, yeah, if temperature, ice cream is positive, right? Positive. AC, guys, AC sales, air cooler, that is also positive, right? That means in winter season only we will buy more ice creams, we will buy more ACs or air coolers. Fine, we are having these two. Agree? Now the point here is both are positive. That's fine. There is, we understood both some positive relationship that is existing. But how much is the positive? Everything should be quantifiable, right? When you're studying stats or machine learning, anything, when you're studying, you should be able to tell. You cannot say, hey, yeah, this is strong. You cannot say ice cream is strong, AC is very strong. Something is very, very strong. That will not work, right? But that very is how much. You should be able to specifically mention this is on a scale of 10, this is 5. Okay, on a scale of this, it is 5. Because you see, you will get results, right? So you will get results 100% of some, say 80% or something. Okay, if it is CGPA, you might be on a scale of 10. You give marks, right? So obviously that should be quantifiable, right? You cannot say, yeah, I got good marks. My friend got still good marks. My other friend got not that so good marks. So if I say that, you will not understand, right? Okay, that's fine, but how much? Because good and very good, there might be very different. Okay, 50 marks and 90 marks is also, you can say, good and very good, but 50 will consider almost fail, right? 90 is almost like first class distinction. So you cannot simply say. So the problem with covariance is that the values which you are getting, right, it is, you cannot compare. Because for some, if you give for temperature and ice cream, it might give you some, as I said, some 1000 rays, and temperature and AC, it will give you some 3000. So but what is 1000, 3000, you will not be able to understand. Okay, that is a fundamental problem with the covariance. Now since we brought this correlation into picture, this guy will also study the same concept. But the very important thing with this guy is the output. Remember, guys, correlation is the most important thing. Okay, first we'll start with covariance, but we'll not use covariance anywhere, because as I said, there is having a fundamental problem. The concept is same, but everywhere you will use correlation, and this is extremely important, because the first thing which you are going to do, if given a data frame, when you are trying to start the machine learning part, or that is one part, or in the any interview also, first thing they will ask you, what is a correlation? Because if you're not able to understand correlation, that means you don't know how to find out if two columns are related. If you don't know how to find out if two columns are related or not, fundamentally there is no point in studying ML, right? Because అసలు 2 పాయింట్స్ 2 కాలమ్స్ లో రిలేషన్ ఉందో లేదో తెలియకపోతే అసలు ట్రైనింగ్ ఎలా చేస్తావు, మిగతా వాల్యూస్ ఎలా కనుక్కుంటావు? గెటింగ్? సో నౌ ద correlation, the extremely important point of correlation is its range of values. Okay, its range of values. So just to mention the range of covariance could be covariance, guys, not correlation. The range of covariance could be minus infinity to plus infinity. Okay, minus infinity to plus infinity. Getting? So that's why I said it can give you any value based upon the strength of the given values, negative or positive. That is the problem. But coming to correlation, the range of these values would be definitely from -1 to +1. Fine, -1 to +1. That is very, very helpful. Fine. So that has changed the complete cinema over here. Fine. When you are having a range from completely minus positive to positive infinity to negative infinity, lakhs of values or some crores of negative value based upon there is no sense in it. Fine. So that's why we will ignore this. We will use the concept and we will use this. So here, can you see? It's getting from -1. It could be -1 or 0 or +1. Done. The whole concept what we have studied is shrinked or brought down to one single line. That is a beautiness of correlation. -1 to +1. Whatever, any value you take in the world, 2 columns you take, that should, if you apply correlation, it will give you a value whose range will be, it will not be greater than +1, it will not be less than -1. It will be somewhere between these two. It could be +1, it could be also equal to -1, but it will not be less than this, not be greater than. So here, as you can clearly guess, if a value is greater than 0, okay, if a value is greater than 0, that means it is positively correlated. Okay, if two columns x and y correlation value is greater than 0, that means positive, that means those two are positively correlated. Agree? But just understand, positive correlated means don't assume that they are positively increasing. They might be negatively decreasing also. But if one is increasing, other should also increase. One is decrease, other should also decrease. Okay, don't get mixed over here. Just positive correlation. If the correlation is positive, that means both are moving in the same direction. Increase, increase, decrease, decrease. Agree? Here, can you see? Increase, 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 or decrease, decrease, decrease. Positive correlation. Fine. If the value is this. Similarly, if the value is negative, if two values x and y value is negative, then it's called negative correlation. That means there is correlation exist. There is very wonderful superb relation is existing. Negative correlation is also sometimes very, very helpful, because instead of knowing where you are winning, you should also know where you are failing, right? Sometimes where you are failing, understanding is very, very important. So where it is causing some effect negatively, that is very, very important. So negative correlation is, there is very good relationship existing, but it is negative. That means increase, decrease, decrease, increase. Fine. This is negative. See, negative, increase, decrease, decrease, increase, increase. Fine. Some other cases, 0, no relationship, shoe size, salary, etc., etc., no relationship. Clear? Is this clear, guys? Let me know. Is this correlation clear? Are you able to understand why correlation is important than covariance?
Yes, sir.
Yes, sir.
Okay, fine, perfect, fine. So now here there is one more point, simple point. So now, as I said, if the value is positive, what are the possible values for a positive correlation, guys? What are the possible values for a positive correlation columns? It will be starting from 0.1, because if it is 0, it is no correlation. Okay, just 0.000, greater than 0. Okay, I'm just taking 0.1. From 0.1 to 1, any value, if you are able to see positive value, that means those two columns are having very good positive correlation. Fine. And obviously, you should understand, if the value is more, it is very strong positive correlation. If the value is less, it is weak. It is not weak, yeah, it is not that great positive correlation. It is still positive correlation, but not that great. That means if x and y values is 0.9, that means there are extremely strong correlation. If one is increasing, other one is definitely increasing. Okay, that means, see, if one is increasing, other is definitely increasing. There might be some, if x and y, these are positive but not that great, it's just 0.2. Okay, this positive correlation only, but just 0.2, a bit positive. That means it might be something like this. The graph is not directly increasing. If it is directly increasing, it will be like this straight line. It is increasing but not that. fastly. Okay, it will be this. Okay, the value. So here also, if you see in this direction, if the value is very much close to -1, okay, if it is -0.8, -0.8, that means it is very much negatively correlated. Okay, this will be very much negatively correlated. If it is very near to zero, that means it is not that great negatively correlated. Okay, if it is not that great negatively correlated, fine. So here don't think like -0.2 is greater than -0.8. No. Okay, if it is closer to zero, any value, if it is closer to zero, the effect will be less. That means if it is this direction, it is less positive correlated. If it is this direction, if it is less negatively correlated. Okay, if it is closer to +1, that means it is very strongly positively correlated. If it is closer to -1, it is very strongly negatively correlated. Okay, so now just to summarize, whenever you are seeing a value, the way how you can understand it is, fine. So they will say, hey, the correlation between two columns is like, let's say, plus 0.7. Okay, here you need to just focus on two things. One is sign, second thing is value. Okay, sign will tell you plus or minus. Here sign plus will tell you the direction of the correlation, and value will tell you the magnitude of the correlation. So here positive, the moment when you see plus, that means it is, there is some very good, not good, we don't know good or bad, fine. So if you see only plus, that means some positive correlation exists. How much that is? 0.7. So sign will give you direction, that means positive. Value will give you magnitude, that means 0.7, very close to 1. Okay, that means this will be very strong positively correlated, fine. If you have -0.2, minus sign will give you direction, that means two columns x and y are negatively correlated, that means one increase, other decrease. Okay, but how much strongly that is happening? That means if x is decreasing by 10 units, is y also increasing by 10 units? Negative correlation, right? Negative correlation, that means if one increases, other should decrease. That means if x is increasing by 10 units, if y is decreasing by 20 units, okay, that means what? It is not perfect correlation, right? So if both are decreasing at this, if the change is exactly the same, then that means what? You can say it's a very good negative correlation. But let's say if x is increasing by 10, y is decreasing by some, for example, 2. Okay, if it is decreasing by only 2, something like that, if it is not equal, then you can say there is negative but not that great, fine. So in this case, that's why you should always just see sign and magnitude. Just by seeing 0.5, okay, good. Not okay, decent positive correlation. -0.9, very very strong negative correlation, fine. 0.1, almost no correlation. But if you want to consider very very minute positive correlation, getting, guys? Now will you be able to understand, if given, just if someone gives you value, can you understand whether it's a positive or negative, and understand behind the scenes what was happening, how those both are correlated according to those graphs? Can you visualize these graphs by seeing just this value? By seeing this values itself, you can visualize this and understand whether the graph is going up or going down, fine.
Yes, sir.
You got it, right? Fine. So now that is the correlation concept, fine. So I hope you, by just seeing the value, you can make a quick understanding, fine. Now the formula, see the formula for the correlation is, correlation formula in statistics, if you see, yeah, this will be the guys. Okay, so it's very very simple, very very simple. So if you see the covariance formula, so it will be the same. So xa minus x bar, ya minus y bar, whatever you're doing here, also you're doing the same thing, xa minus x bar, ya minus y bar. But in the denominator, you are doing the same thing with the square. Okay, but here in the denominator, you are doing with only dividing by sample size. But here if you see, xa minus x bar, y minus, here xa minus xa whole square, ya minus y dash whole square. Okay, y dash or x bar, anything that is mean. Okay, so here also we are having x column, y column, x is having a list of columns, y is having a row of columns. Okay, mean of this will be x bar, mean of this will be y bar, same x bar, same y bar. Take every value from x, first value, separate it from mean, take first value, separate it from mean, y, add all those like that, 100 points. In the denominator also do all this. Fine, whatever the value we are going to get, that will be definitely between -1 to +1. Getting? So here, if you're interested, just you can observe these two and make a quick understanding that here the reason, the problem which you are facing over here in the covariance, that is the range is -infinity to +infinity. We are trying to solve that. We are trying to solve that by controlling the denominator. Getting? So here you can see the denominator is nothing, but if you control the denominator, the values will be keep on decreasing, right? Do you get that? So if you're having 10 by 2 what? 5. So if you're increasing the denominator, if you're increasing the denominator, the value will be decreasing. Sorry guys. So same thing here. We are trying to play with the denominator and make sure these two values, the correlation coefficient values, will be confined to -1 to +1. That's it. Nothing greater than or less than these two values. Clear, guys?
Yeah, Santosh.
Okay, fine. So now, yeah. So now, since we had a good understanding about covariance, correlation, okay, you can the formula of covariance, you can forget it, okay, because you are not going to use it anywhere. But the concept is same. So don't forget the concept: positive correlation, negative correlation. Fine. And now, if at all, if I ask you, Sirisha, if I ask you like salary and let's say salary is decreasing, okay, and what do I say? Number of tours the family is going in a year, okay, family tours is decreasing, okay. If I say a salary is increasing, number of tours is decreasing. So can you tell me, Sirisha, like what type of correlation exists between these two?
Positive.
Positive. Sure. Meghana, do you agree?
Yes, sir. Positive.
Okay, perfect. Thank you, guys. You saved me. Okay, so that means if salary increases, twos, we can also make more twos, salary decreases, this to increase. Okay, so there is no reverse relationship. That's why it's positive. Perfect. So now we have seen the example, we have seen the formula. Fine, we have seen the fine. So we'll see the practical code also, because whatever you study, ultimately it should be done in code, right? So now if I quickly show you, so yeah, so just to mention, as you can see here, so you are seeing some word called as Pearson. Okay, you are seeing something called as Pearson. So this is nothing but this is a person who has like invented these things or created these things. Fine. So now there are mainly two types of correlation coefficients, guys. It's called Pearson correlation coefficient or Spearman. Okay, these two are the guys' names. Okay, so it's called Pearson coefficient or Spearman correlation coefficient. Okay, both they are like two different formulas. Okay, very similar formulas. Fine. Now, the concept is same, exactly same. The range is same, minus 1 to +1, everything is same. Okay, but the way how they approach is slightly different. The values might be slightly different. That means if you get 0.7 to positive, here you might get some 0.8. Okay, slightly different. Okay, that's it. Okay, just for your understanding, just remember, if how many types of correlation coefficients you have, it's called two types, Pearson and Spearman. Okay, so now coming to words, obviously you should remember some words, guys. Concept is fine, I hope you understood the concept, but this correlation is actually called as you can see, this words you should remember. Okay, what is this called? It's called Pearson correlation coefficient. Okay, the covariance is covariance, but correlation is called correlation coefficient. Okay, Pearson correlation coefficient, it's called. Okay, and the formula is this. Okay, and we have seen the example. Now if I show you how you can do practically, it's very simple. Okay, so you have something called as SciPy. Okay, so we as we can see, you have NumPy. Okay, you have pandas, and you also have SciPy. Okay, SciPy is for statistical concepts. We use the package. Okay, from here SciPy.stats. Okay, you are importing something called as Pearson R. Okay, simple Pearson R. So with that, okay, I am importing some data, okay, called as auto.csv. Fine. So if I just quickly want to show you this auto.csv, okay, df.head, if I do, okay, So you see, you're having mpg and weight, okay, some miles and weight. Fine. So now if I take one list as df of weight column and df of two other column, okay, and to this Pearson, okay, see, to this Pearson, okay, I'm passing two values, okay. How, why I'm passing, this is a function, okay. Just switch back to the function concept which we studied in the Python. So as I said, you'll slowly start seeing all of them here. So this is a function, you need to pass some argument. So you are passing these two arguments. Argument one is column one, argument two is column two, you are passing, and it will give you two values, okay. So the value which you are getting over here in the correlation, that if you print, it is saying minus 0.878, okay. That means weight and mileage, okay, weight and mileage, because if the weight is more, okay, if the weight of the vehicle is very more, the mileage will be less. Agree, guys? Do you agree? Because bike will give you good mileage, car might give less mileage, okay, and a more costly or a bus will give you very less mileage, okay, and aeroplane will give you extremely less mileage. What mileage is what? How many kilometers you can travel for a given liter? Okay, if there is more weight, obviously you need more power, more fuel to move the body, right? So same thing over here. So if the weight is increasing, mileage will decrease. Fine. So those two columns I'm giving over here, and as you can see, the Pearson correlation, what we are getting here, minus 0.8. Clear? Minus 0.8. First understand sign, minus, negative. That means one increasing, other decrease. And how much that, what is the strength of the relationship? This is the direction of the relationship. Strength is 0.8. That means very strongly. That means if weight is increasing, mileage is definitely greatly decreasing. Okay. So that's how you can clearly understand. Okay. And you can just play with other columns also, I would say. And if at all, as I said, right, so here you can also have something called as, let me see, spear, you will have something called as, yeah, spearman r, okay. So as you can see, there is spearman r, okay. So if I use spearman r in this sense, see, as I said earlier, you got some 0. See, as you can, if I show you Pearson, observe Pearson, you got minus 0.8. But if go for spearman, you are getting minus 0.9. Okay, it will be two different ways. Two persons study the same concept, given similar formula, slight different. Okay, but mostly you can go with Pearson. That's fine. So this is how you can, you have inbuilt. So whatever you are doing, we have studied the formula, right? So formulas everywhere you will see the formula, that is important for your understanding, but nowhere you don't need to write or remember any formula at all. Okay, so all this formula or this formula, so you don't need, you can remember for interview purpose, okay, but you don't need to manually do at all. Okay, you already have the Python packages readily available for almost anything you're going to study till machine learning. Fine. So you directly have this from the package, just import that. Okay, just use it, pass the columns you want, minus 0.8. Okay, so you can just take some examples, take some other data frame which you have seen in the Python, okay, and just pass different columns which you know. Okay, you can easily data is available over like internet. Download some data frame, give the two columns, pass it to Pearson, and understand negative sign and the magnitude. Okay, so understand how they are changing. Fine. So then you'll have a good relation, good understanding of the concept. Fine. So this is the about the practical code, how you can see. Fine. So formula, I would say, yeah. So that would be the regarding this. There is one last concept regarding in this I would say topic. Okay. So which is actually a very important concept, guys. So do you have guys 5 minutes of time? Fine. So let me continue. See, now coming to now you understood correlation and covariance, right? But there is a important concept here. Okay, it's called correlation and causation, guys. It's called correlation and causation. It's a very interesting concept, actually. Okay, this, yeah, if you go to some decent company, right, like MNC, people might ask this actually. See, we studied that x, there are two columns till now. We studied two columns, x and y. If x is increasing, decreasing, all this concept we have studied. Okay, but now comes a situation very interestingly. just because just because two columns are increasing, okay, two columns are increasing, might not necessarily mean they are correlated. Okay, just because two columns are increasing might not necessarily mean they are correlated, and just because the two are correlated might not mean that both are caused each other. Okay, I understood that you did not understand. Okay, but let me explain this will be interesting. See, let me tell you. In a particular winter season, okay, in a particular some season, if you see the ice cream sales are increasing. Okay, ice cream sales are increasing. Fine. And also, let's say somewhere in the same area, crime rate. Okay, crime rate is also increasing. Okay, crime rate is also increasing. Okay, these are two statistics you got. Fine. So if you plot a graph, as you can see, as ice cream sales are increasing more and more, and you can also see crime, the values of the ice cream as they're increasing. Okay, you can also see there is an increase in the crime rate. Okay, that means in this season, if the ice cream sales have gone from uh, 10 10 units per hour to like some 100 units per hour. Okay, as you can see, it is increasing. You can also see that there might be increase in the crime rate also in the particular season. Okay, then you can see, then that means what, it will be something like this. Okay, but the problem here is you should be smart enough to understand, just because these two are increasing, you should not think that these two are what, correlated. Fine. So these two are not correlated, or these are not related to the causation concept. Okay, but fine. See, let me, yeah, before it's causing any confusion, I'll just tell you one concept. Okay, so that you will understand this better. Okay, see guys, what I'm saying here is you're having something called as correlation causation. Okay, what is the meaning of causation? That means one column is causing the other column. Okay, one column is causing the, causing means what, is the reason for the other column. Okay, is reason for the causing the other column. Okay, other column. But just because it is causing that column, okay, just because it's causing that column, you cannot say that they are correlated. Okay, that is relation, correlation, causation. I'll tell you, for example, simple example I will give you, you'll understand. Okay, let's say you are having a phone. Let's say you are having a phone, mobile phone. Fine. Now when you are trying to send a message, it is not working. It is saying what? The phone is getting stuck. The phone is getting stuck. Fine. Now, what is the problem of stuck? It is because of lack of memory. Okay, no memory. No memory. Getting? No memory. But now, the problem over here is the message is text message you are not able to send is the one problem. The actual reason over here is what? The actual reason is not what it is, the no memory is the reason. Fine. So what is causing this? What is causing this text message not able to send? The thing what is causing here is no memory. No memory. That means lack of memory. If you're getting no memory, no space. Okay, no space is causing, because if there is no space, obviously you cannot send a text message, right? So if you have no space, no, if there is no space, okay, if there is no space, sorry, yeah, if there is no space, then you cannot send a text message. Fine. So this no space issue is causing this problem. What it's causing the problem? Stuck. The phone is getting stuck. Okay. So that is causing the problem of this. Getting? So, but the fundamentally, if you try to understand over here, the lack of the RAM is the causation of these two, whether the phone is getting freezed or whether you are not able to send the text message. It is because of what? It is because of the lack of the RAM. Okay, because of this, it is causing the phone freeze. Also, it is causing the text message problem. Okay, but you can see a direct correlation between phone freezing, okay, phone freezing, and the text message not working. Okay, if you are trying to send, text message, more and more text message. Okay, for example, let's say you are trying to send, if you're trying to send a small message, okay, small message, fine, you can see the phone might allow it for some time. Okay, and it gets stuck. If you are trying to send a large message, if you're sending a large message, the phone might get stuck immediately. Fine, the phone might get stuck immediately based upon the space that is available. Fine. So now there is existing some correlation between the text that is not working and the phone that is getting freezing. Okay, but what is actually causing this? The causing is because of the lack of the RAM. Okay, so point I'm trying to make over here is, every time you see two columns, okay, every time you see two columns, Sometimes it could be that one is just causing the other column. Okay, one is just causing the other column. Fine. But that night, sorry, that might not be actually getting correlated with that. It is just causing and leaving. Okay. See, lack of RAM, whatever you are having this, right? It is just causing this to happen, and this is just it is happening. It is also causing the text message not working. Okay. But the actual correlation what we are able to see here is between these two columns. Okay, the phone is getting freezed and the text message is not working. The correlation might exist those two. Okay, because lack of RAM is same. It will just cause hundreds of problems. Fine. All these problems might have some correlation between these two, between each other. Getting is this getting, or is this confusing? If it is confusing, I'll try to see some more example. I'm just trying to understand if you're getting the point, because see, this you might not be able to use this in practically, but it is important to understand because there is a beautiful article written on this itself, stating that in nature you will have lot of columns. Okay, lot of relationships where one column, okay, one will just cause the other column, but it is not necessarily correlated. It will just cause and it will stop. Okay, for example, okay, if I just try to give an example, just if it will cause, it will just cause another column and then it will not start the correlation. Okay, so if I just say uh, elections, okay, because of the elections you can see a cause in the crime rate. Okay, I will try to give this example. Let me say, let me know if you're able to understand this. See, because of elections, during elections, now this elections time, right, you can see an increase in the crime rate, guys. Agree? First, let me go step by step, guys. Agree? Do you agree? During elections times there might be some increase in the crime rate?
Yes, sir.
Yes. What type of crime rate, Sirisha?
Corruption.
Corruption, correct. Fine. So we have seen so many black money got caught here and there. Fine. Now that means what? Election is just causing the crime rate to increase. But now if you take this concept and try to apply the correlation, you cannot directly say that. That means if crime rate is increasing, you cannot say there are elections happening. Agree? Getting the point?
Yes, sir.
What is the correlation? If X is increasing, Y should increase. X is decreasing, Y should decrease, or some relationship. But here, because of elections, crime rate might increase. That's fine. Agree. But you cannot directly say, bring the correlation concept and say, hey, these are correlated. As you can see, increase. Now you cannot apply reverse way. That means you cannot say, hey, if in a particular city, if the crime rate is increasing, you cannot conclude that elections are happening over there. Getting? It is just causing and it is leaving. That means one of the cause for the crime rate could be elections. Fine. But there might be all different reasons for the crime rate. Illiteracy could be, poverty could be, different reasons could be for the crime rate. Okay, but one reason is elections. Okay, all these are causing. Okay, all these are causing. Fine. They are not exactly correlated. They're just causing because of poverty. See, because of poverty, there might be crime rate. Okay, increasing. Okay, but you cannot simply say if crime rate is increasing, poverty is increasing, or if crime rate is decreasing, poverty is decreasing. No, you cannot say, because in America there is very extremely less poverty, but still there is high crime rate. Agree? Getting?
Yes,
Sir.
sir.
Yeah. So in US there is extremely less poverty. There will be no very less poverty, but you cannot conclude, hey, there is no crime rate. Okay, but still that is correct. This is also correct. What? Because of poverty you can have some crime rate. That is also correct. But because of crime rate is increasing or decreasing, you cannot comment on the poverty rate. That is also correct. So there is a different kind of relation. That means what? Here it is causation. Fine. The poverty will cause the crime, but you cannot say there is exact relation that is existing. Same thing. Illiteracy might cause the crime, but you cannot directly say because of increase. If illiteracy decreases, you cannot say crime rate completely decreases. No, because very literate people might also commit crimes. Fine. So just try to understand Generally you will have positive, negative, no correlation, that's fine, but always don't directly jump. Given two columns, don't directly go and try to understand, hey, this positive or negative. Okay, just give it a thought for 1 second, whether it is just causing and leaving. Okay, elections are just causing the crime rate and leaving, that's all. Similarly, if it is just causing and leaving, or it is exactly correlated, to understand if it's exactly correlated, always see from both sides. One increasing, other definitely increasing, one decreasing, other definitely decreasing. If that is existing, then fine, correlation. If not, if it's just causing, then that is just causation, it's not correlation. Understood, guys? Just causation. Okay, fine. So I hope that you got the idea on the causation part. Fine. So this is just for understanding interview purpose. Fine, but just try to revise the correlation concepts, the code and the concepts part. Fine. So yeah, I understand it's getting late for your college. Fine. So are we good, guys? Are we good?
Yes, sir.
Is the class clear? Is the class clear, honestly?
Yes, sir.
Okay, perfect. So fine, that's all for today. Hope you understood. So tomorrow we are going to study the frequency of different columns like univariate and bivariate columns. Okay, so that will be the next concept. Fine. So fine, that's all for today. Okay, so thank you so much for joining.